Okay, let's start, guys. So I hope you had a good lunch. I hope I won't fall asleep because of my digestion during the talk, and you neither. We'll start. We start now because we have a lot of things to say about this topic. So this conference is called Extending the Gradle Android Plugin. We will discuss a little bit how to just play with what the Android Gradle plugin from Google is doing, and how, as users of this plugin, we can just manipulate, configure things, and mostly interact with this tool. So my name is Eyal. I'm working at Genymobile on a project you may be heard about. It's called Genymotion. Who knows what Genymotion is? Okay. One of my colleagues just raised the hand like, I know. Yeah, a few guys doesn't know, but I will tell a little bit more about that because it will give you a good context about what we've done and why we've done that. And I'm also a lucky guy, part of the Google Developer Expert Program. That's a program at Google that helps speakers to speak. You have the slides right here. bit.ly/extend-android. You can just get it right now if you want. Okay, so what we will tell about. A few questions. Who already built an Gradle plugin? Okay, not at all of you. It's good. So we'll have a few minutes to tell about the basics. I won't go deep really on what you must do and what boilerplate you need to implement to do a Gradle plugin, but I have on the reference, there is a link to a talk I gave about this topic, you know, how the Gradle plugin 101. So read that if you feel that you don't have all the basics of that. Then we will have a part that is not about Android, it's just about Gradle plugins in general, how to build a good DSL. Then we will tell about how to interact with the Android Gradle plugin, how to test your plugin that is linked and interacting with the Google Android plugin. And if we have time, but I'm not sure, how to publish a plugin that you developed. So the basics, let's be quick. First, you have three kinds of Gradle plugins. The first is the build script, you know, the build.gradle that you, as a user, use, is considered like by the Gradle engine like a plugin, really. So actually, you're already doing Gradle plugins even if you didn't know that. You have also another kind which is called script plugins. This is actually the Gradle plugin API that you use and that you just put on your project, on your .gradle files. But we won't tell about that because it's not that clean, in my opinion. And it's not the thing we really want to release to our friends or users. And what we will tell about is more binary plugins. So it's a Gradle plugin that you will bundle into a jar, put on a repository to make the people download and use it. Okay, another basic, you know, the Gradle task is a piece of work. You can manipulate it with a few endpoints. You have two examples, do first, do last, etc. This is the Gradle tasks are types. You can inherit from tasks from one on another, so you can extend it. And you can link the task one to each other. And to link, the concept in Gradle is called a dependency. And there are two examples also of methods that you can use to link two tasks. And actually, when you link your task, when all the plugins that are part of your project are created, they are finished to create their task and link all these tasks, it will build what is called a task graph. Okay? These are basics. I won't go deeper into these details, and we will try to focus more on other things. But it's a few basics that you must know absolutely to just understand correctly this talk. Another basic is what compose a Gradle project. So basically, most of the time, it's a Groovy project. It contains a few things. First, because it's a Gradle project, you have a build.gradle. You have a plugin class, which is the entry point of your plugin. You have a descriptor, just to simplify, telling that where is the entry point. You have, of course, your logic, and your logic is contained on task, your custom task that you will implement. And you have an extension. The extension is the DSL, the language that you will expose to your user to configure to let the user configure your plugin and tells you what it expects from your plugin. So just a few examples that I can give you. Gradle plugins, you have a Java plugins, Groovy, of course, the Android plugin that I told you about. Okay, another point that is really interesting and really important to understand is that on the Gradle build, you have 3 important phases. The first is the initialization. It's when you have several modules on your Gradle project, it's the phase that where the dependency between all these projects are resolved. There is another phase which is called the configuration. It's actually execute all your build.gradle files, and you will have the build task graph that will be built at this moment. And this configuration phase is also named the evaluation phase, and we will tell about that a little bit later. And then, when your task graph is built, you have the execution that will, that will execute one route of your task graph. Okay. So everybody get the point, right? So during all these steps, and mostly on the evaluation phase, some events can be fired by Gradle, and as a plugin or as a simple user, you can just handle it. During the evaluation, you have, for example, two things that are triggered before evaluate, after evaluate. And also during the task graph creation, you have others. And most of the time when you are building a plugin, one thing which is really commonly used is after evaluate. So you will grab the hook when the evaluation is finished, and you can just put code in it to do your stuff. And you make sure that the configuration has been correctly be read by Gradle. Okay, so this was really basics. Now we will focus more on how to build a DSL, not how to build a DSL, but how to design your DSL and what you should put on. And we will tell a little bit more about what we've done at Genymotion. So when I tried to create this talk, I was thinking about, okay, how to define a good DSL for Gradle projects. So first, the DSL must be readable. Okay, your user, a new user that arrives on the build.gradle that have been developed, that have been written by another guy, he should be able to read and understand it. Okay, then it must be flexible. When you have something complex to express, to tell on a DSL, it should be nice if the DSL is clean and easy to use to express these complex ideas. And I will give you an example about how you can make it flexible, of course. It must be intuitive, so it's easy to use, and talkative. Talkative because you will see the discoverability of Gradle plugins and DSLs is not that good. There is no auto-completion, things like that. So the only way for your user to have a feedback from you is that you tell to him something is wrong. Okay, make it readable. Okay, so when you want to create an extension, when you want to create the root of your DSL on your plugin, you will use this call. For all the people that already built a plugin, I think you already done that. So project.extension.create, then you give the name of your extension and the class behind that, okay? My extension, in this case, with a few arguments. So my extension is a very simple Pojo or Pogo, if it's Groovy, file, class. you see here, there is the constructor receiving the arguments. You have two parameters that I exposed, myInfo and myList, and we put just default values on the constructor. This is a very, very common and simple use case. And on the user side, so what will be the result? People will have in the build.gradle, they will apply your plugin, which is called my plugin in this case. My extension will be called, and you will have a block telling and configuring your plugin, okay? So they can change, for example, my info, the parameter, the property my info, or my list. Okay, this is a very simple use case. And now I will tell you a little bit more about Genymotion. So starting from this point, Genymotion is an Unreal emulator. And what we wanted to do with our plugin is that the people will be able to declare devices directly on their build.gradle. And when they will launch their instrumentation task, we will launch directly and create, if needed, the devices that they declare on their build.gradle. And at the end of the test, we will close these devices and destroy them if they want. Okay? So with just a few lines of declaration, they will be able to do that and to run that on the, any developer computer or on the CI, on the continuous integration server, like they want. Okay, this was the main purpose. And we thought about what we want the people to configure and to declare into this plugin. So this is an example, just a sample of the thing that the people wanted. And this is a first draft of what we wanted to put on our DSL. First, the people can configure Genymotion with, I don't know, if they have a server license, they can just put the information directly on the build.gradle. They can change the SDK, the SDK path if they must use a custom ADB from Android Studio, for example, the standard ADB. And so this is the first part. They can configure like the setting button on the Genymotion application. And there is another thing. Do you all see the text right here? Yeah? Because it's pretty at the bottom. So they will be able to declare devices. And in this example, you have two devices. One is called Nexus 5. And another one is called Nexus 4. And the first one is running Lollipop, the other one KitKat. Okay? So they can declare directly on their build.gradle these devices calling these methods. Okay, this is the first draft about what we know we can expose to our user. But this is not that clear. And we will try to work on this draft to make it more readable for our users. Okay? So the first thing is that what we wanted to do to make it clear is that when you want to configure Genymotion, you will have a block dedicated to this. So we transform the draft from this to this. You know, you have a config, and then you will have several properties that you can set, which is really easier to read. So what you can do for that is to nest an extension into another extension. And this can be done very easily. So on my project, on my apply method, on my project endpoint, entry point, sorry, I call project.genymotion. Genymotion is now my extension. Then extension.create. And I give the name of this nested extension, and the POJO behind that, the type is Genymotion config in this example. And now I have something which is more readable than when I had before. So just with nested extension. Okay, so now let's focus on another part of the draft I shown you and make the things easier to understand and to express for the user. Okay, so let's focus on the device. We previously had this method, device, where the people can fill parameters to declare one device. And when there are several devices that they want to launch, they just call this method several times. And this is not really clear. And actually, what I gave you was a very simple example. But for example, my user would like to change the width and the height of the screen and the density. So it would just add a few parameters. And if the user wants to install several APKs or push some files, it will also, you know, with these parameters, add other information to this method, okay? This is not that good. I don't know if you like this DSL. I just can't read it. It's really annoying. So we try to work on this to make it a little bit better. The first thing that we try is to use the name parameters. You know, in Groovy, you can name your parameters. Some other talks already tell about that. So if we change the same method, and if in our documentation, for example, we write this thing on another way, you will have this result, right? So you will have the name of the device, the template of the device, the width, etc. This is more expressive. This is more clear, but it's not that good. Really, it's really verbose. People must express everything. They have this column at the end of the line each time. It's not really good. And another point that is really blocking is that the name parameters in Groovy are ordered. So if you miss one, if you don't want to configure this, just one, it won't work. So that was not a good solution. What we wanted to achieve is something really better and something inspired for what we've seen on the product flavors, for example. You know, on the Android plugin, you declare product flavors, you declare a new flavor, and then you have the specific property for this flavor. And you keep the default one, and you declare only the thing you want to change. And if you apply this to our use case, it will be this. So we have the Genymotion extension at the top. Then we have a block, which is devices. Then inside devices, we have our both devices declaration. And now let's tell a little bit about what's the code behind that. So devices in our extension will be a method, okay? Devices. And this method will receive as only parameter a closure. Actually, this closure will be executed. We will see just later. And both Nexus 5 and Nexus 4 declaration will be stored into what is called a container. Okay, so in the concept, that's what's happening. When you see these kind of DSL that are flexible, let's see what's the code. Let's see how you can just code this thing, this kind of patterns. So on your apply project, the entry point of your project, you will instantiate an instantiator. This will be used later to create some objects you will see. Then on your project, there is a method which is called container, where you fill the type of device, the type of object you want to create automatically. And in our case, each time we have a new device declared, what we want to create is a device launch, because for each device you will have a launch that will be programmed. The second parameter of the container it's waiting for a factory. So the factory that will create each instance of device launch. Okay, and you will receive a container right here. And when you create your extension, the Genymotion extension, we just added as an argument the device launch previously created. And then, just let's wait for this to disappear. This is very common on projects. I'm sorry. And this is very common. You will see on a lot of projects. When the evaluation finishes, that's at this moment that we will create our task and we will inject into the graph task. Okay, so this is very common, and you will see a lot. And that's what we had to do for our case. Talking about the Genymotion extension, what we have actually is that we receive the container that have been created. Actually, the name of this container is a named domain object container, and it will contain device launch objects. This device launch is received on the project as an argument on the project constructor. Extension constructor as an argument, and we just store it locally. Okay. And we have our devices method that I told you about that will receive a closure. When we will receive this closure, we will call device launch, and we will call configure on device launch, passing the closure. So we just let Gradle instantiate all the declarations that have been done by the user as a series of device launch objects. And then we will be able to use them. On the factory, it's just a simple class implementing a name domain object factory interface, sorry. And the only thing that you must do is just to create, to override the create method and use the instantiator to create device launch. There are other ways than using instantiator to create dynamically these classes. But that's the most common way, and that's the most recommended way to do it, because it will have other, it will enrich actually your the device, the object you create. But I won't go into this detail. We don't have time. So device launch object is a very simple object that takes on the constructor just the name of the name of the object. In this case, the string name will be Nexus 5 and Nexus 4. Okay, so with these few boilerplates and few concepts, you can just easily create a DSL that is, as I told you, flexible. You know, you have something complex to tell. Your user has something complex to tell. He must create, you don't know a number of devices. He must override a few properties on these devices launch. And that's the way you implement it. Okay, make it intuitive. So now we have our DSL that is complex but easy to declare for our users, but there is still something that is not perfect to me. This part of this talk is more subjective, but that's more the way I like to do. So the problem I see here is that on the install property, you see this list of devices that is not really clear for the user. To use, you see there is a hash map here, Groovy hash map. It's not perfect, okay? And we will try to work on it. So starting from this point, we will, what we want to achieve is to use this DSL. So people will be able to install a series of APKs, and pull after can be called several times with name parameters from and to. So it's more declarative, more easier to use. And how you can do it? Same thing, it's pretty easy. Install will be on device launch a method, taking a series of paths, and these paths will be added into just a list of install paths. And pull after will be, again, a method getting two parameters, from and to, and put in a hash map. Okay? Just this way, you change your DSL to make it something smoother and easier to use. Make it talkative. As I told you, there is no discoverability on your plugin's DSL on Gradle. There is no suggestion in your IAD, and there is no documentation that is embedded directly in your build.gradle. Right now, I didn't see that. And you have a problem because you have a plugin on one side, and you have your documentation somewhere on the web. And you need to have something on your plugin that does the link to this documentation. And the best thing to do is actually to talk to your user. So when something wrong it's happening. When you use not the good DSL, you must try to catch these things and to use the log, simply the log, to just tell him what's about. And what you would think, it would be the good way to go for him. And really, that's the reason why I told you, this is technically not part of the DSL, but for me, it's really part of the DSL, because that's the way you discuss with your user. The user talks to you using the syntax you've seen before, and then you must answer him when there is something bad happening. So as a designer of your plugin, you must take the choose of your user at one time, and try to think about all the errors he could do and how you can put him, what message you could give him to put him on a good direction. Okay, So we discussed about the DSL, and we have a good DSL. So that's what happened for our project. Then we had another challenge to achieve. It was to inject our task and to discuss with the Android plugin. So if you read the documentation, there are 3 endpoints that are pretty interesting that you can use. The first is application variant, then you have library variant and test variant. You know, the variant is the combination of project flavors and build configuration, okay? Application variants, library and test variant will let you access to all the applications variants, sorry, I just made a thing with that, but that's really pretty clear. When you want variants that are related to application, use application variant for the library, etc. And for all the variants that are supposed to run test variants. So how do you use it? What is the DSL for that? On your build.gradle file or on your project, you will call android.applicationvariants.all. And then you will open a closure. This closure will have one parameter, which is called variant. And then you will access to each variant, because actually this closure will be called iterately, and you will have access to all the information contained in this variant. You will have the name of the variant, you will have some tasks that are linked to this variant, and depending on what you want to do, you will be able to interact with it. One thing which is very important, when you call all on the application variant or any collection like this, it will launch the generation of all the tasks from the Android Gradle plugin. So it's really important that you call this after the evaluation. So you make sure that the configuration have been totally executed by the build, and you won't do bad things that will avoid the project of your user working correctly. Okay, I told you that this is on the documentation, and it's true. You have the link to the documentation, tools.android.com, and you have a dedicated page for that. And there is on this page a part which is called manipulating task, a section that is explaining you, and you have a big table with all the properties that you can find on the variants depending on what kind of variant you are calling. And this is very interesting because that's the way for you to go. But there is one problem, is that this documentation page, I see some guys from Google laughing, looking at this slide, is that it's about 30% wrong. It's here, so it's a good entry point. So you can understand the logic, but some things that you will read will not be good. The good documentation is the source code. It's 100% accurate because that's really what is running on your project. So how you get the source code from the Gradle plugin? Just a clone on the Android open source project, looking for the tools-based repository, and you check out on the tag, this tag. For example, the last one currently is Gradle _2.3.0, which is a little bit old, sorry, because the last release is 2.3.3, if I'm not wrong. And so I discussed a little bit with Google guys here, and they told me that they are just a little bit late. It's just a temporary phase, let's say, and they will update all the release. You won't have the preview on the AOSP, which is kind of obvious, but when a plugin is released, their aim is that the source code is available. But there is a solution. When you don't still have access to a clean code that you can just check out using it, you can download the jars, and you have the source.jar on the Maven bundle, and you can just unzip it, and you have access to all the source code. You won't be able easily to rebuild this by your hand, so if you want to modify, it's not that the best way to go. But oh, that's fine. I thought we were late. Okay, so the source code is available directly on the binary that already released. Okay, if you really have something that you cannot do with this Git repository. There is another good documentation, is your debugger. So why I tell you that, of course, the source code is good, but you don't really know where to go at the first glance. So when you have a problem, you use your debugger, and the best way to use your debugger with Gradle is to do some instrumentation tests. So using instrumentation tests, GUnit tests, you will be able to just put breakpoints and have information directly on what is the task graph, for example, or what the variant that you receive on the hook I shown you before. Another point that is really important is that you must not assume that explicit values are always the same. And we will see, I will give you an example about that, but this caused me some problem at what point for when I developed this. So you must use dedicated properties. You know, the properties that are told, that are explained on the documentation. Even if the documentation is false, you must use these kind of properties. Okay, now let's talk a little bit what's happened to us and why I tell you now, because it's, you know, it's very conceptual, but here is what's happened. So I had these test variants because, of course, our plugin just work only when there is a test, an instrumentation test. And what I wanted is to grab the connected Android test task, you know, the task that that is launched for a variant when an instrumentation test is running. And the documentation told me that the property on the variant is called connected Android test. Okay, so I use this one. And then I run my tests. And I've seen that actually this property doesn't exist. So that was a problem because it was on the documentation, but that was not on my instances running for my project. So what I've done is that I use my debugger, trying to explore a little bit what there is on the variant. And what I found was pretty interesting. So on variant, there were a property called variant data. And on variant data, there is another property containing a task, connected test task, the name of this property. And the name of this task was connected debug Android test. That was pretty interesting because that really looked like what I was looking for, right? So this was the first step. And I went a little bit further with the source code. And on the source code, what I've seen is that on the test variant class, you have a method that is returning variant data.connect test task. And this method is called getConnectedInstrument test. And reading that, I knew that my variant actually had a getter directly to the property I was looking for. I didn't need to go to variant data to get this information. And actually, the good DSL, the good property was not the one on the documentation, but was connected instrument test. And I used this one, and we are now compatible using this API from the plugin 1.0 to the very last one, including the alpha. So this has not moved since this moment. So that was the good API, the good parameter to use. Okay, and I told you right before that you must not assume that a static value that everybody knows will remain on the source code of Android concerning the task name. I will give you an example. I run a test displaying the name of the task, of the connected instrument test task on different versions of the plugin, the Android plugin, and you will see how the name changed. So it was a long time ago. On the 1.0 version of the plugin, this name was connected Android test. And 5 months later, on the 1.2.0, it was named Connected Android Test Debug. 3 months later, the name of the task changed again, and it was called, at this moment, Connected Debug Android Test. Okay? So something that you know, that you use to manipulate, that you know working, should sometimes, when it's just about name of task, you should not consider it like all the time real. And you must use as a plugin properties that are the good API exposed. And since this moment, the task name didn't change anymore. So now it's something like 2 years that it's the same name. Yeah, I told you, internals are changing a lot. And the only way for you to make sure that your plugin will continue running is to have tests that ensure that what you are coding will work with a new version of the plugin. So how to test an Android plugin? First, the Gradle plugins are Gradle projects, so it's very standard to test, okay? We all know that there are mainly 3 kind of tests that we can do on any project, but we will focus on Gradle and plugin projects. So you have unit tests that won't require any Gradle API that you want to. So if you have, I don't know, just a business logic class that doesn't mess with Gradle, we won't talk about that because we all know how to do this, right? You have integration tests that will use a stub of a project, and we will see how we can manipulate, how we can play with it. And there are functional tests. Functional tests are really build that you will execute from the beginning to the end, and then you will check what's happened during this build, okay? So integration tests, to achieve this, there is a class, which is an API, which is called Project Builder, that allows you to create a stub of a project. And you will see that you can launch the evaluation on this project to check all the tasks and things like that. So how to add, how to bootstrap your project, of course, repository, my event central, you add JUnit, this is just a detail. And now we want to test the extension. Okay, let's try to develop our first Gradle plugin tests. So what we are doing, we use the project builder to create a project. Then we apply our plugin, our own plugin, which is called Genymotion in our case. And then we check that, in this case, that the extension is on the good type. That's a very simple test, just to show you how to use the Project Builder API. Now we want to test the task, a new example. Okay, we create again, our project uses the same thing, and we want to check that we have a Genymotion task, which is an instance of Genymotion task, okay? And we run this test. And you will see it will fail. Why will it fail? It will fail because it doesn't know the Genymotion task. This task seems that have not been created. We created our project, we apply our plugin, but at this moment the task was not here. Okay, why is it wasn't here? As I told you, many projects wait for all the build.gradle being fully read to create their task and to inject their task and to interact with other tasks in the task graph. And that's exactly what we had to do, because we were waiting for our user Gradle finish reading our configuration, the configuration of our plugin, and we waited also for the Android task finishing to be created. So the problem is that you must evaluate, but there is no API to evaluate. Let's evaluate. You know, maybe it will work. This is not on the documentation, really. So you run call evaluate method, and actually, magically, it's working. And at this moment, you are pretty happy. Yeah. So, okay, I didn't invent this method. Of course, it exists, and I heard about that on the web. And I've seen somebody talking about this method precisely, telling that it was an internal method and it should have a supporting mechanism for this kind of thing in the near future. So the guy telling that sentence on the forum, on the Gradle forum, was Luke Daly, that is present at this summit, and it was in 2011. So I discussed with a few guys from Gradle here just yesterday, and I told them this story. And I think there will be something maybe on the project builder in the near future to be able to do this kind of thing. I hope so. But now you know, okay? Until they have this official API, there is this thing that you can use. that is not documented. Okay, what about Android? Because that was just simple, standard Android plugin. So what you must do on your project, you will add a dependency on the Android plugin, the Android Gradle plugin version you want. Okay, so you add it on test compile because you will use it for your tests. Then you will create the same project with the project builder, but you just must give a route to a stabbed Android project for that the Android plugin needs. Then on your stub project, you will add the Android plugin. And there are a few mandatory properties that you must set. Okay, when you have this, you have just a wrapper for a standard Android project running correctly. What is the folder, the root folder I gave? It's just a very simple hierarchy. So you have a manifest on the simple project. You have just a local property. On the local property, you just must set the SDK directory. Actually, if you're the computer running your tests has the Android _ home variable environment, this is even not mandatory. But what is mandatory is the Android manifest, and you see mine is completely empty and it's working perfectly. That's just the thing you need. Another thing that we've done is that we categorized we annotate our Android-related tests with one category. This allows us to run only Android tests when we want to run. You will see several tests on different Android plugin versions. Then, just an example of things that we want to test. We create different project flavors. Then we evaluate on our project. And we want to check that for each variant, test variant, the connected instrument test task got a dependency to our Genymotion task. So that's what we've implemented. That's our use case. That's what we needed to test. But just to give you an example of things that you can do after your evaluation, you iterate again on this variant and test if your plugin interacted correctly with the Android plugin. An important point is that you don't know what the version of the Android plugin your user will use when he will use your plugin. So you must ensure that there is a compatibility. And for that, I told you, the only way is the test. And the thing that you must do also on your test is to control from outside of your project the version of the Android plugin. And to use that, there is a very powerful feature on Gradle, which is called Gradle properties, allow you to inject values from outside of your build. So what we've done on our build.gradle, we set our default Android version. We deliberately set this default value to plus, so we have the last version of the Android plugin. And if from outside the user sets the Android plugin version, we just change the value by default. And on the test compile, we inject the Android version dynamically. Okay? And when a user wants to use or want to run the tests with a specific version, there is this -p Android plugin version parameter that he can add. Okay? And what we've done then, something. When you have this thing, then you can just use your CI to inject a different version and to run the tests iteratively on all the version you want. Something important, if you want to make it to test the very last version and notably the beta and the alpha and the previews of the project, you must use JCenter because it's for now where the last version of the plugin are hosted, and of course the plus to have the very last alpha preview of 2.5.0, I think, right now. Okay. One drawback of this methodology is that you must switch the Gradle version on the fly, because for each version of the Android Gradle plugin, you have one version of Gradle that is compatible with. And another drawback is that you must run all these tests from your CI, and with a script on your CI, and you cannot do it directly with just a simple Gradle task. So I won't go into details, but this is a very small sample of what we've done on our CI. We have a Python script running all the tests with a kind of matrix of a Gradle version and list of Android plugin versions, and we iterate on this table to test our plugin with all the Android version we know, respecting the Gradle version which is compatible with. Okay, so I finished with the integration test, and I will finish quite, I think we are already late. Oh, we are late. For the functional test, there is an API which is called the test kit, which is quite interesting because you will be able to build a project on the fly, to write a build.gradle like your user would do, like we've done almost with the integration, but you will be able to test for a real build. And this allows you to test what is the result of a build. So you will test the full chain. You will test, you will create your build.gradle, you will inject your plugin on this project, and you will run the build. And you will be able to test, of course, yeah, something interesting also. You can choose the Gradle version you want to run your project on for your test directly from this API, the test kit API. There are some limitations, is that with that, you just have access to the result of the build. You won't be able to access, for example, in our case, the previous case, we wanted to check the whole build task graph and check if we have our tasks on the good places on this graph. So you cannot do it with this one, because you will test the thing when the build will be finished and the graph will be done, because everything will be closed. Or you can avoid that by adding a test into the the user's build.gradle file. So that's something the Google guy, not the Google, but the Gradle guys are doing. But to be honest, I'm feeling a little bit not confident with this kind of thing. It's because you add on your assets of tests some tests that you want to implement. So it's really not that perfect to me. But then sometimes you can just decide that it's a good way to go. OK, I don't have the time to talk too much about publishing, but just to let you know, when you have your jar, there are the plugin portals from Gradle that you can where you can reference and declare your project. If you can host really easily your project on Bintray. If it's open source, just put it on GitHub, and it's free on Bintray. And if you want to be part of JCenter, just post it on Bintray, and then you have all the documentation to tell to Bintray that you want to be on the JCenter repository. And there are just a few tools that you can use to publish automatically. Okay, just to conclude the conference, I will give you 3 references. The first was the talk I told you about, how the Gradle plugins 101. All these slides video are links, so if you have the slides, you can just click on. There is an interesting talk that I've been given last year, which is called Idiomatic Gradle Plugin Writing, which is interesting about the DSL that I told you about at the beginning. And about the Gradle test kit. Last year, there were a very good video by Benjamin, I don't remember his family name. So testing the build with test kits. If you want to learn a little bit more about test kit, an API that I didn't told you about too much because I didn't have time. I hope you liked this talk, and I see you somewhere if you want to just discuss with me later. Thanks.